Hey guys, so in the last lecture we have seen the chapter that is belt, ropes and chains, and that chapter we have completed. So there were total 5 lectures in which we have discussed all belts and chain drive and rope drive. So today we are going to discuss next chapter, that is friction, clutch and brake. So in this chapter we have total 5 lectures, sorry, total 6 lectures. So today first two lectures will be friction, then clutch, and then belt, friction, clutch, and brakes. So let's start with today, that is friction. So the first lecture, that is friction. So what we're going to discuss in friction, so we'll start with introduction to friction. So first, that is introduction. So what do you mean by friction? So when a body slides over another, the motion is resisted by a force that is called force of friction. So that is called force of friction when two bodies are slided over one another. It is impossible to produce a perfectly smooth surface. A block is placed on a surface. The interlocking of projecting particles takes place due to the surface roughness of the surface, and the force of friction on the body is parallel to the sliding surface and acts in direction opposite to the sliding surface. So if this is a surface and this is a object which is sliding in this direction, so the friction force will act in opposite direction. So to be reduced force of friction. Now to increase the force of friction in process where the power is transmitted through friction, attempts are made to increase it to transmit more power. So example is friction clutch and belt drive. So even the toughness of a nut and bolt is dependent mainly on the force of friction only. So that we'll see further that what is friction clutches and how it is used. So let's what are the types of friction? So there are total we can say mainly 2 or 3 types of friction. So we'll see types of friction. So what are the types of friction? So this is uh, so first is dry friction. So it occurs when the relative motion between two completely unlubricated body, they are divided in 2 types. So that can be a solid friction and another will be rolling friction. So for solid friction, I can give an example that if there is a surface on your, suppose you are on a table, there is a table in which there is a duster which you are sliding over the surface. So that you can call it as a solid friction. So that is when two surfaces having sliding motion related to each other. It's called solid friction. Now the second is rolling friction. So what is rolling friction? So friction due to rolling of one surface over another is called rolling friction. So for example, I can say that when you write on a piece of paper, so when you write on a piece of paper with your pen, so your pen is having a ball inside it. So that ball is moving over that paper via rolling. So it is rolling and it is not sliding. So that type of friction is called rolling friction. And for industrial example, it is used in ball bearings. So in ball bearings rolling friction is used. So now the third type is sorry, only two category in dry friction, that is solid friction and rolling friction. Now second type is skin or greasy friction. Skin or greasy friction. So what do you mean by skin and or greasy friction? So when two surfaces in contact have minute thin layer. So if two surfaces is having a thin layer in between, minute thin layer of lubricant between them, so it is known as skin or greasy friction. So higher spots on the surface break through the lubricant and come in contact with the other surface. So this layer is very thin. So generally grease. So in generally in your bicycle, generally the chain or is greased. Uh, Greasing is used. So this is very thin, so it can come in contact with the the slider, but there is always some grease over there, some skin over there. Then third is film friction. So here when the two surfaces in contact are completely separated by lubricant, so there is no contact between those two sliding surfaces, so there will be a film every time. So there will always be a film, so there will be no time where film is not present. So when two surfaces are completely separated by lubricant, friction will occur due to the shearing of the different layers of the lubricant. So due to this shearing, the friction will occur, and this is known as film friction or viscous friction. So now the viscosity will come into in concept. So therefore it is called viscous friction. So these are various types of friction. Now let's see laws of friction. So what laws governs the friction? So let's see laws of friction. So experiments have shown that the force of solid friction is directly proportional to the normal reaction between the two surfaces opposes the motion between the surface and depends upon the material of the two surfaces. It is independent of the area of the contact and velocity of the sliding. So, what does it mean? So, let's see the coefficient of friction. So, uh, suppose this is a surface. Sorry. So, this is a surface. This is a normal surface. And on this, there is a bob. There is a mass, which is having weight and downward direction W. So weight always x in downward direction. So it will have a normal reaction force, let's say Rn. So this is N for normal and R is the reaction force. So let this body of weight W rest on a smooth and dry plane surface. Under the circumstances, the plane surface also exerts a reaction force Rn on the body, which is normal to the plane surface. If the plane surface considered is horizontal, then R would be equal to and opposite to W. So Rn will be equal to W. So this both forces will be equal to each other. Now let small horizontal force F be applied to the body. So suppose small horizontal force F we are applying to move the surface, so the along the body is unable to move. So suppose F we are applying, so body is unable to move. So so the friction force, so the friction force will also X on this body. So suppose I am applying F force and this body is not moving. So and resisting force will also X in opposite to that direction, that is we are calling suppose F dash. So if I am applying suppose 1 Newton force, it is not moving. So this F dash will be also equal to 1. If I am applying 2 Newton, it is not moving. So F dash will be also 2 Newton. So as F is increased, the relative force F dash is also increasing accordingly. So F dash and Rn. So F dash and Rn, the friction and the normal reaction force can be combined into single reaction and with the angle. So suppose uh, this is the reaction. So suppose this is the resultant force, that is R here. So this is creating an angle theta. So here, so here we can call it as R cos theta, which will be equal to, that is Rn, so which is equal to W, and R sin theta, which is F dash, will be equal to F. So at a moment when the force F would just move the body, so when it starts moving, the value of F dash or R sin theta equal to F. So the value of F dash, so this is the F dash or R sin theta, is called the static force of friction. So this is called static force of friction. So when it starts moving, so that F dash will be called the static force of friction. So an angle theta attains the value phi and the body is in equilibrium under the action of three forces. So F is in horizontal direction here, W is in vertical downward direction, and R, it is in an angle phi with the normal. So we are considering a phi angle uh, at which it starts moving. So with the normal inclined towards the force of friction. So let's so here let's F dash, so this force of friction F dash is proportional to Rn. So F dash is proportional to the force Rn. So if we remove the proportionality sign, so we'll get that F dash is equal to mu Rn. So mu will be equal to F dash upon Rn. So tan phi, so if I want to find tan phi or tan theta, here it will be F dash upon Rn. Therefore tan theta is equal to mu. So therefore theta, the angle of limiting angle of friction, theta will be equal to tan inverse mu. So this is called limiting angle of friction, or simply angle of friction. Now let's see the next topic, that is inclined plane. So what is inclined plane? So from the name suggests that a plane which is inclined at an angle alpha. So this is the normal horizontal plane, and this is an inclined plane at an angle alpha. So this is an inclined plane and our object of weight W is on this inclined plane. So it will have the weight in downward direction, so that is W. So it will create the normal reaction force in perpendicular to the object, so it will be Rn. This is the normal reaction force, and as the body is moving in downward direction, so the friction force will act in opposite direction, that is F dash. And so here what the various angles of due to weight will be. So here suppose this is alpha, so let me just draw some lines. uh, so let me draw some lines here. So what we are getting here is, so what will be this angle? So this angle will be alpha. So uh, now what are the components of W here? So here it will be W cos alpha, and here it will be W sin alpha. So W is cos alpha and here W sin alpha. So when a body is at rest on an inclined plane making an angle alpha with the horizontal, the forces acting on the body will be W, this is weight of the body, normal reaction Rn, F dash, the force resisting the body. So this friction force is self changing force till the body doesn't move. So under equilibrium condition, when body or under equilibrium condition, what will be F dash? F dash will be, if we resolve the forces, so F dash will be equal to W sin alpha. So W sin alpha is equal to F dash. Now W cos alpha will be equal to Rn. So W cos alpha will be equal to Rn. So if the angle of inclination of the plane is increased, so if this angle is increased, so the body will just slide down the plane of its own. So when W sin alpha, it is F dash, will be equal to mu Rn. So when this will be equal to mu Rn, so it will start sliding. So what is Rn? But Rn is W cos alpha. So W sin alpha, that is F dash, is equal to mu into W cos alpha. So here so W, if we compare this and this equation, both equations, so we are left with here sin alpha is equal to mu cos alpha. So we will get, if I bring this cos alpha on downward side, so we'll get tan alpha is equal to mu. So alpha will be equal to tan inverse mu. But what is tan inverse mu? It is nothing but theta. That is angle of limiting friction. So the maximum value of angle of inclination of the plane with the horizontal when the body starts sliding of its own is known as angle of repose or the limiting angle of friction. So this angle is the same as the angle of limiting friction. So this is an inclined plane. Now let's consider a body moving up the plane. So suppose a body is moving up the plane. So motion up the plane on this inclined plane only. So suppose, let me draw the diagram. So this is an angle alpha. This body is having weight w, and it is moving up the plane, so it is moving in this direction. So it is having, suppose, a force at an angle phi. It is having a force at an angle phi here. So the friction force will act in this direction, that is mu rn. So the normal reaction force will act perpendicular to the surface, that is Rn. So the resultant force here will be R. So now here consider a body. So here we are considering a body moving up the inclined plane. So it is moving up the inclined plane under the action of a force, the action of a force F. So as the motion is up the plane, the friction force, that is mu Rn, would act downward along the plane. So the body is in equilibrium under the action of three forces, that is W, external force F, and resultant force R. So if we apply the Lamis theorem, so this 1, 2 and 3 forces are there, so that it will be F divided by sine. What are the angles here? So what are the angle here? What is this angle? So it is 180. Now let me see what is the angle here. So so let me draw a free body diagram here to find the angles. So suppose this is R, so this is F, so this is R, this is F, and this is W here. So we want these three angles. So we know that total angle will be 360 here. So now if I draw a few diagrams to get the angles, so let me draw first a vertical line here. So now what is this angle? So this what is this angle? So this angle is nothing but, here this is alpha, now this is phi, so this angle is also phi. So now what is the total angle here? The total angle will be, so first let's consider this angle. So from F to W as an angle theta. Okay, so this angle we are considering as a theta. Now this total, this line is, this total is 180 degree. So 180 minus theta. So this angle will be here. Here it will be pi minus theta. This is whole pi, 180 minus theta, and this angle will be phi plus alpha. So this angle will be phi plus alpha. So the total angle will be phi plus alpha plus pi minus theta here. Now what is this angle? So this angle will be, this total is 360 degree. So that will be it will be 2 pi. So it will be 2 pi minus this all angles. It will be theta plus alpha plus pi minus theta plus theta. So this will be theta, theta gets cancelled. So here uh, pi and 2 pi, so pi gets cancelled. So here we are left with pi minus theta plus alpha. So this angle will be pi minus theta plus alpha. So we got all the angles. So F will be here sine pi minus theta, theta plus alpha here. So here it will be 180 minus alpha plus that is, sorry, here it is phi. So it is phi plus alpha, so it will be alpha plus phi. And here the another, according to Lamis theorem, the other angle will be here W upon this. So it will be W divided by this angle. So this angle is sine, that is that is phi plus alpha plus pi minus theta. So here I can write here it as, here I can write it as pi minus theta plus phi plus alpha. Here if I add or subtract pi, so this pi, and here also that is add or subtract pi to the sign, so it will doesn't make any difference here. So we are subtracting here, so the 180 pi will get cancelled, so we are left with here sine alpha plus phi is equal to W upon sine here theta minus alpha plus phi. So the force F will be equal to, if I make a subject of F, so F will be equal to W sine alpha plus phi divided by sine theta minus alpha plus phi. This is the force for moving up the plane. So if the force applied is horizontal, that is theta is equal to 90 degree, so it will be a horizontal surface. So if I take this theta equal to 90 degree here, so it will become cos. So the force will be equal to W sine alpha plus phi upon sine 90 minus alpha plus phi, so it will become cos. So F will be equal to W sine alpha plus phi divided by cos alpha, so it will be equal to cos alpha plus phi, so it will be equal to sine upon cos, so it will be equal to F is equal to W tan alpha plus phi. So this is the same equation which we derived for horizontal uh, plane, and if the force is applied parallel to the plane, that is 90 plus alpha, so what will be the equation? So if theta is equal to alpha plus 90 degree, so in that case the force will be equal to uh, here it will be uh, here instead of theta, here instead of theta it will be alpha plus 90 degree, so alpha alpha will get cancelled, so we are left with here is W sine alpha plus phi divided by cos 90 minus phi, so it will be cos phi. So if I open this bracket of sine alpha plus phi is equal to sine alpha cos phi plus cos alpha sine phi, so we will get F is equal to W sine alpha cos phi. So cos phi gets cancelled, so here we are left with sine alpha plus cos alpha and sine phi. So sine upon cos will be tan phi here. So it will be F, the friction force F will be uh, W sine alpha plus mu cos alpha. So this is the equation for moving up the plane. So F will be minimum if the denominator on the right hand side is maximum. So we'll see in the next lecture. So thank you very much.